Didn't have time to go over the solution to the last problem in class, so I decided to make this video to explain how it works. So first we had to do a construction. We had to build an angle ABC, and this angle had to be an acute angle. So here we have 3 points, and they are going to form an angle that is an acute one. The next step of the construction was to build a circle centered at B. And of course, this circle that we built is going to intercept rays BA and BC in 2 different points. One of the points we're going to label D, and the next point we're going to label E. The next steps of the construction was to build 2 other circles centered at D and E with the same radius as the radius of the first circle. So building the second circle actually centered at D, and now building the third circle centered at E gives us this picture. Now the second and third circles, they intercept at this point here, which we're going to call P. Well, now we're going to add some other elements to this drawing because they're going to be important for the last questions. So one of the things that we are going to have to draw later is the line from B to P. And also we have to build the quadrilateral BDP. So we need to add this segment here, DP, and this segment here, P. Now, we also have to draw the segment D. And right now the drawing is a little bit clouded, so we're going to remove the circles so that we can see better the picture and understand better what's going on. So on the last page of the formative, question A says, draw quadrilateral BDPE. Which type of quadrilateral is this? This quadrilateral here is a rhombus. And then when we draw a line BP, the question in letter B is, what is the relationship between this line, BP, and the angle ABC? Well, the line BP is going to be the bisector of angle ABC. And finally, we had to draw the line DE, which is this one, and we had to discuss whether or not the statement is true. In quadrilateral BDPE, the diagonals cut themselves into halves. So you could either know from a property of rhombuses that the diagonals do cut themselves into halves, or you could notice, for example, that all of those 4 little triangles that we have here are congruent to each other. So let's see, for example, that this triangle here is congruent to this triangle here. So this segment here, where the cursor is common to both. So we can use the reflexive property to say that they are congruent, of course. Also, segments BD and BE, they are congruent because they are radii of the same circle. And finally, this angle here is congruent to this little angle here because BP is a bisector of angle DBE. So we can use side angle side to conclude that those 2 little triangles here are congruent to themselves, to each other. So one of the conclusions is that this segment from D to this point here is congruent to this segment here. And we can prove similarly that the other diagonal, BP, is cut into half by the other diagonal.